Hi students, welcome to Brilliant Author. In this video, we will be discussing the PYQs of the chapter Matrices and Determinants. Okay. In this session, we will be discussing some important and typical matrices, the conventional properties, and in this video, we will be discussing the conventional method and also some shortcuts for doing the questions. Okay. And please remember, do keep your notebook and a pen with you while watching this video, and sometimes you need to do problems with me. Okay, and let's start. This is our very first question. If P is equal to 1, 0, 1 by 2, 1, then they ask you to find what is P raised to 50. Okay, before doing this question, let me tell you the specialty of this matrix. Okay, let's consider the matrix a matrix A. A is equal to 1, 0, K, 1. Okay. And you know how to find A square, right? A square can be found, you'll get A square by multiplying the matrix A with itself. And after multiplying, it will be like this: 1, 0, 2, K, 1. Okay. So what is the power here? Will be attached with the coefficient of K. Okay. So what will be A raised to N? A raised to N is equal to 1, 0, Nk, 1. Okay. And there is one more matrix which is the transpose of this one, which also holds the same property. That is, if B is equal to 1, 0, K, 1, then also it will be like this. Okay. It will be B raised to N is equal to 1, 2K, 0, 1. Okay. So the given matrix is P, right? So what will be P raised to 50? It's very easy. P raised to 50 is equal to 1, 0, 50 times 1 by 2, 1. That is 1, 0, 50 times 1 by 2 is 25, 1. And that will be option A. Therefore, A is the first answer. Okay. A is the answer. Let's move to the next question. Okay. A matrix P is given. Root 3 by 2, 1 by 2, minus 1 by 2, root 3 by 2, a square matrix. And another square matrix is given, okay, which is same as the matrix we have discussed before. And they have mentioned what is Q. Q is P into A into P transpose. And another matrix is given, P transpose into Q raised to 2000 into P. And it is given as A, B, C, D. Okay. So you need to find 2A plus B minus 3Z minus 4D. Okay, so what you need to do here is find out this matrix and compare it with the corresponding elements A, B, C, D. Find A, B, C, D and substitute it here. That will be easy. But here is what you need to observe. Okay, see, you need to find Q raised to 2007 first. For that they have given this data. And substitute that value here, form another matrix. Okay. By looking at the numbers, you'll have a perception like it's a very big, enormous question. Okay. But it's a very easy question and it's a typical matrix. It holds some special properties. And if you use that properties, actually there is no calculation needed for doing this one. Okay. Which I will show you how to do it. Okay. Before that, just remember the numbers here. It's root 3 by 2, 1 by 2, minus 1 by 2, root 3 by 2. Have you seen those numbers anywhere? 1 by root 2, 1 by 2, root 3 by 2. Those numbers are corresponding values of trigonometric functions, right? Okay. So, let me show you one important A special matrix. That is A. Okay, I am assigning the name A. A is equal to cos theta minus sin theta, cos theta minus sin theta cos theta. Okay, there is another matrix which is B, that is cos theta minus sin theta cos theta. Okay, whatever property this matrix holds, it will hold for this matrix also. Okay, so what will be A square? A square is, as I stated before, if you multiply this matrix with itself, you will get A square, right? A square will be cos 2 theta sin 2 theta minus sine 2 theta cos 2 theta. Okay, whatever is the power here, it will be the coefficient of theta here for all the elements. Okay, so what will be a raised to n? A raised to n is equal to cos n theta sine n theta minus sine n theta and cos n theta. Okay, this is what a raised to n is, and b raised to n will be like this. Okay, there is another property, that is, hope you know what is orthogonal matrix, right? What is an orthogonal matrix? See, if you multiply a square matrix with its inverse in any order, and if you are getting an identity matrix, then those matrices are called orthogonal matrix. And this matrix is an orthogonal matrix. That is, the matrix A is an orthogonal matrix. Okay, just keep that in mind. Okay, and this the two properties which this matrix holds is, like first one is a raised to n. Okay, the power will be attached as the coefficient of each of the elements. Okay, and it is an orthogonal matrix. That is, if you multiply this matrix along with its transpose, the result will be an identity matrix. Okay, and we can start this question. Okay, then this question is done. Okay, if you know that property, this question is over. Okay, there's nothing to do here. And before that, my question is, could you express the elements in terms of cos and sine just like in this matrix? That is, could you express the elements in terms of cos and sine as in this matrix? Yes, right? Because this is cos 30, this is sine 30 minus sine 30 cos 30, right? Therefore, I am rewriting it. That is, P is equal to cos pi by 6 sine pi by 6 minus sine pi by 6 cos pi by 6. As we know that it's an orthogonal matrix, right? Okay. So they have given P and you need to find Q raised to 2007 to obtain this matrix, right? So let's find Q square first. So what is Q square? Q square is equal to Q into Q, that is P A P transpose into P A P transpose. P A P transpose. Okay. So what is P transpose into P? P transpose into P is I. Okay. Therefore, this is reduced to I. What is A into I? A. And what is A into A? A square. Okay. Therefore, it will be Q square is equal to P A square P transpose. Okay. Therefore, what will be Q cube? P A cube P transpose. And what will be Q raised to 2007? It will be P A raised to 2007 into P transpose. Substitute this value here and you will get P transpose into P into A raised to 2007 into P transpose into P. And P transpose into P, you know that it's an identity matrix. Again, here also it is an identity matrix. Identity matrix into A raised to 2007 is A raised to 2007 itself into I also yields the same value. Okay. So the result will be what? A raised to 2007. So how to find A raised to 2007? It's very easy. This is a matrix we just discussed before. The only parameter that will change if you multiply A with itself is this element. Okay. Therefore, A raised to 2007 will be 1 2007 Okay. So that's all. The problem is over. Nothing. No calculation was needed for this one. Okay. And just substitute A, B, C, D here. You will get the corresponding answer. That is 2A means 2 into 1 plus B is 2007 minus 3 into 0 minus 4 into 1. Okay. This is 2009 and 2009 minus 4 is 2005. Okay, that's the final answer. Hope we got it. Okay, I hope it's clear. Let's move to the next question. Okay, next one. Very much similar to the previous question. Okay, but the question is changed. Okay, the concept is same, but the question is changed. Okay, A is equal to 1 by 2 into 1 root 3 minus root 3 1. Okay, it's very much similar to the previous one. If you multiply the matrix with 1 by 2, okay, it will become 1 by 2 root 3 by 2 minus root 3 by 2 1 by 2. Okay. So I'm writing in, okay, I haven't explained the question. Sorry. Okay, so some options are given below. You need to pick the correct option. Okay, in all of the options, mostly these types of questions are time consuming. You need to go through all of the options. But here, it's not that much. Okay, you don't have to do that much. Here, if you look through all of the options, the power is somewhat same. Okay, that is a raised to 30 and a raised to 25. In some questions, the powers might be different. In some, it will be a raised to 50, some a raised to 40, like that. So you need, if you are considering all the options, you need to do all the numbers which are given there. Okay, so I am multiplying this a with 1 by 2. Okay, and we will get 1 by 2 into 1 is what? 1 by 2, and it will be root 3 by 2 minus root 3 by 2 and 1 by 2. This is what a is. Okay, and then I am expressing it in terms of cos, that is a is equal to, this is what, cos 60, right? Cos pi by 3 sin pi by 3 minus sin pi by 3 and cos pi by 3. Okay, and what you need to find next is a raised to 50 and a raised to 30 and a raised to 25. And what is a raised to 30? That is cos 30 pi by 3 sin 30 pi by 3 minus sin 30 pi by 3 and cos 30 pi by 3. Okay, cos 30 pi by 3 is cos 10 pi. And what is cos 10 pi? Even integral multiples of pi for cos is 1 and for odd is minus 1. Okay, therefore a 30 is equal to, this is 1, and sin 10 pi, integral multiple of sin is 0, you know that, and this is 1. Okay, so a raised to 30 is an identity matrix. Okay, and what about a raised to 25? A raised to 25 is equal to cos 25 pi by 3 sin 25 pi by 3 minus sin 25 pi by 3 and cos 25 pi by 3. Okay, so you need to find the values of cos 25 pi by 3 and sin 25 pi by 3. Okay, we can do it here. That is a raised to 30 is equal to identity matrix. Okay, therefore a raised to 20 cos 25 pi by 3, that is cos 8 pi plus pi by 3, and that is 1 by 2, right? Yes, in the first quadrant. Like that, what is sin 25 pi by 3? Sin 25 pi by 3 is root 3 by 2. So a raised to 25 is equal to 1 by 2 root 3 by 2 minus root 3 by 2. Okay, and this is equal to this matrix, right? And a raised to 25 is equal to a. It's almost over then. Okay, so a raised to 30 is equal to I and a raised to 25 is equal to a. From that, you need to identify the corresponding options. Okay, I think C is the correct answer. Why? Because a raised to 30 is what? I. Substitute it, you will get I. And what about a raised to 25? That's a. Another a is here. Okay, a minus a will get cancelled to a null matrix, and which is equal to identity matrix. So basically LHS is equal to RHS. It's matching, so that will be the correct answer. Okay, easy one. Next one. Okay, our very next question. For the matrix A is equal to 1 minus alpha, alpha, beta, it is given that A into A transpose is an identity matrix. Okay, and you need to find the values of alpha raised to 4 plus beta raised to 4. See, for the students who does not know this theory, they will go for finding A transpose, then multiply A with A transpose, then equate it with identity matrix, resolve the values of alpha and beta from the respective equations, and then they will substitute this to get the final answer. But if you know this theory properly, if you know that special matrix properly, it will take around 15 to 20 seconds to do this question. Okay, just that much. I will tell you how. My question is, could you convert this into the cosine matrix, that is cos theta minus sin theta cos theta matrix, which we just discussed before? We can convert it, right? How? Which angle of cos is 1? Cos 0, right? Or cos pi. Okay, whatever it is, I am taking the angle 0. Therefore, A is equal to cos 0, right? Since it's an orthogonal matrix, I'm converting it into that trigonometric matrix. Okay. For cos 0 minus sine 0, sine 0, cos 0. Okay. And if you apply the angle part, it will be 1, 0, 0, 1. The problem is over, right? It's an identity matrix. If you compare alpha and beta, you will get the answer. What is alpha? Alpha is 0, and what is beta? Beta is 1. Okay. Therefore, alpha square plus beta square, 0 square plus 1 square is what? 1. Okay. Done. Okay, we can move to the next question. There is an alternative method for doing this question, which we can discuss a bit later. Okay, there is one more method actually, that's also a shortcut. Next one. Okay, and it's A is equal to 0 to QR, P, Q minus R, P minus QR. And it is stated that A into A transpose is an identity matrix. I3 means an identity matrix of order 3. Okay, and you need to find modulus of P. It's not determinant, actually it's modulus of P. Okay. Okay, so what will you do for this question? See, the thing here is, normally most of the people, what they will do is, they will form again, like in the previous question, they will find A transpose, multiply it, equate it, and then they will obtain the value of P. But there is a suitable shortcut for this one. By using that method, you can do this question within 10 seconds. Yes, within 10 seconds, you can do this question. Okay. See, for an orthogonal algebraic matrix, okay, if it's an orthogonal trigonometric matrix that was discussed before, for an orthogonal algebraic matrix, okay, which I'll tell later in the next slide, okay. Let's consider a matrix A, B, C, D, E, F, G, H, I. Okay, I'm taking 3 by 3 matrix at first, and let's take this matrix A, and it is stated that A is an orthogonal matrix, that is A into A transpose is equal to A transpose into A is equal to identity matrix. It is given that already. Then this the elements inside this matrix will hold a particular condition, and the condition is that if you take the elements in the column wise, it will be A square plus D square plus G square. It will be equal to 1. In this column, everything, if you square and add them, it will be equal to 1. Okay, like for, this is column 1. Like for column 2 and column 3, you can apply this. Okay, there is one, okay, that is B square plus E square plus F square equal to 1. C square plus F square plus I square is also equal to 1. There is one more property, and the property is that if you multiply the corresponding elements in column 1 and column 2, or any two columns, and add them, the resultant will be 0. That is AB plus DE plus GH is equal to 0. Okay, like that in this case also. Okay, so these are the two things which you need to consider while doing these types of questions. Okay, now if you got this, please note this down. We are going to do that question within 10 seconds. Okay, see, it's an orthogonal matrix, right? So if you square and add any column, the subsequent value will be equal to 1, right? Let's take the first column, since the first column only has P in it, and we need to find P only, right? Therefore, if you square and add the first column, it will be like P square plus 0 square is equal to 1. That is 2P square is equal to 1. That is P is equal to plus or minus 1 by root 2. Therefore, modulus of P is equal to 1 by root 2. Okay, done, understood? That's all. C is the correct answer. Hope it's clear. Next question. Okay, I mentioned before, there is one more method of doing this question. Okay, which one was that? Yeah, this one. It's an orthogonal matrix, right? Therefore, if you square and add the corresponding columns, it will be 1. Okay, that is 1 square plus alpha square is equal to 1. This column. See, I have detailed the theory on the base of 3 by 3 matrix. It will hold for 2 by 2 matrix also. Okay, so in this matrix, if you square and add the elements in the first column, it should be equal to 1. If you cancel this, what is alpha square? 0. Okay, and about the next one, that is alpha square plus beta square is equal to 1. Minus alpha square is alpha square. Alpha square is equal to what? 0. Therefore, beta square is equal to 1. That is beta raised to 4 is equal to 1. Alpha raised to 4 will be equal to 0. Okay, 1 plus 0, that is 1. Okay, that's another method of doing this question. Okay. Next one. Okay, next one. ABC element of real numbers, all non-zero and satisfies AQ plus BQ plus CQ is equal to 2. Okay. If matrix A is equal to ABC, BCA, CAB. It's a beautiful matrix. There was a question based on this matrix in written exam, which was way before, and they found a very beautiful question based on this matrix, which we can detail later, okay, in advance, which I'm talking about, okay. So the matrix is given, it is like A, B, C, B, C, A, C, A, B, okay, and it's an orthogonal matrix. Yeah, it's A transpose into A is equal to A. Obviously, it's an orthogonal matrix, and you need to find the value of A, B, C. And how will you do this? It's a very lengthy question actually if you are doing in another manner, but we can use the shortcut and try to resolve this. Okay, they have given that AQ plus BQ plus CQ is equal to 2 and you need to find the value of ABC. Okay, my question is, there is an algebraic expression or equation, which connects AQ plus BQ plus CQ and ABC. Do you know that? Actually, there is an algebraic expression. Okay, let's check that out. The expression is like this: AQ plus BQ plus CQ minus 3ABC is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Okay, A square plus B square plus C square minus AB minus BC minus CA. Okay, that is the relation. They have already given you the value of AQ plus BQ plus CQ. You need to find the value of 3ABC. For that, you should know the value of A plus B plus C, A square plus B square plus C square, minus AB minus BC minus CA. Okay, very easy question. So, as I told you before, it's an orthogonal matrix. There is a specialty among for the elements in its column. Okay, so what is that? If we square and add the corresponding elements in its column, it will be equal to 1. That is, the first thing is done. A square plus B square plus C square is equal to 1. So, this is equal to 1. And what about if you multiply the corresponding elements of column 1 and column 2, and if you add it, it will be equal to 0. Therefore, AB plus BC plus CA is equal to 0. So, this part was equal to 1 and this part becomes 0. If you take negative outside, it will be 0. Okay, that is 1 minus 0 is 1. And you just need to find the value of A plus B plus C. And how will you find the value of A plus B plus C? To find that, you need to use another algebraic expression. That is, A plus B plus C, the whole square is equal to A square plus B square C square plus 2 into AB plus BC plus CA. This is equal to 0. This is 1. So, A plus B plus C, the whole square is equal to 1. Okay. So, what will be A plus B plus C? That is equal to plus or minus 1. Okay. Therefore, it will be like AQ plus BQ plus CQ minus 3AB is equal to AQ plus BQ plus CQ minus 3ABC is equal to A plus B plus C is 1, right? That is 1 into 1. Okay, and this is equal to what? Okay, we can take plus or minus 1, sorry. A plus B plus C. A plus B plus C whole square is equal to 1. So, what is A plus B plus C plus or minus 1? Okay. So, AQ plus BQ plus CQ is equal to 2. That is 2 minus 3ABC is equal to plus or minus 1. Let me check if we need to neglect any one among the two signs. They have said that it's all non-zero. Okay. So, either it will be 1 or minus 1. Okay. So, 2 minus 3ABC is equal to 1. Therefore, ABC is equal to what? 1 by 3. Or, okay, ABC is equal to 1 by 3. Or, we can write this here. 2 minus ABC is equal to minus 1. Okay. In that case, 2 minus 3ABC. 2 minus 3ABC is equal to minus 1. In that case, ABC will be equal to 1. Okay, but that's not in the option. Therefore, we got two values of ABC. First value is 1 by 3 and second value is 1. Okay, since I have considered both the signs, and this will be enough. ABC is equal to 1 by 3. So 1 by 3 is the correct answer. Okay, I hope it's clear for you. Okay, then we can move to the next one. Okay, and A is equal to 1, 2, minus 1, 4. A inverse is equal to alpha I plus beta A. It is stated that alpha and beta are elements of real numbers. And okay, we need to find alpha and beta. Okay, 4 into alpha minus beta is what we have to find. Okay, so how will you do this question? Two methods. The first method is, you know how to find A inverse, right? You can find A inverse. Okay, then form that though. Just write the equation like that and equate alpha into I plus beta into A. Then add these two, compare the corresponding elements, formulate alpha and beta. Okay, that's extensive conventional method which I have talked about. Okay, but there is an alternate for doing this question. Okay, not for this question, for so many questions we can use this alternative. Okay, the method is called, it's not a shortcut actually. Okay, the method is called Kaye-Hamilton theorem. Okay, we will study this theorem, no, not in plus 1 and plus 2, in higher standards, that is in degree or in BTech, we will study this. Okay, well, you are enrolling for any of them. You will study this. Okay. Okay, I'm not going to dig deep into the Kaye-Hamilton theorem. Okay, I'm just telling the surface of that because if I dig deep inside, it will require more time. Okay, and it is not needed for you now. Okay, and I will explain Kaye-Hamilton theorem for 2 by 2 as well as for 3 by 3 matrices. Okay, you should study that, and so many questions are asking. You can expect at least 3 to 5 questions in total batches. Okay, okay, I will do it. Kaye-Hamilton theorem. Kaye-Hamilton theorem. See, for a 2 by 2 matrix, let's consider, okay, a matrix A, okay, as a 2 by 2 matrix. Okay, Kaye-Hamilton theorem states that every square matrix of order 2 can be expressed in this form: A square minus trace of A into A plus determinant of A into I is equal to a null matrix. That is, Kaye-Hamilton theorem suggests that it states that every square matrix of order 2 by 2 can be expressed as a quadratic polynomial of that matrix in this format. That is, A square minus trace of A into A plus determinant of A into I is equal to null matrix. That means, I will tell you an example. Okay, that is, let's take A as 1, 2, 0, 5. Okay, trace means sum of diagonal elements. Hope you know that. That is, A square minus trace of A is 1 plus 5, that is 6A. And what is determinant of A? 1 into 5, 1 into 5 minus 0 into 2, that is plus 5I is equal to 0. Okay, if you substitute the matrix here, you will get the result as a null matrix. That is, if you find A square and substitute it in here as a whole, you will get a null matrix. This is what Kaye-Hamilton theorem states. Okay, it's for a 2 by 2 matrix. We will discuss this for a 3 by 3 matrix as well. It's slightly different from this one. Okay, CHT, that is Kaye-Hamilton theorem for 3 by 3 matrix, suggests that every square matrix of order 3 can be expressed as a cubic polynomial of that matrix. Okay, that is A cube minus trace of A into A square plus minus of sum of minus of diagonal elements. Okay, plus minus plus into A minus determinant of A into I is equal to 0. Okay, every square matrix of order 3 can be expressed in this format. Okay, hope it's clear. I will tell you one example. That is, if A is equal to 1, 0, 5, minus 1, 0, 2, 1, 1, minus 1. Okay. So, how will you express this matrix in terms of Kaye-Hamilton theorem, or in this as a cubic polynomial of this matrix? That is, a cube minus, what is trace of a? 1 plus 0 plus 5 is 6, right? 6a square plus sum of minus of diagonal elements means the position is 1, 1, 2, 2, 3, 3, right? You just need to add the 3 minus m11, m22 and m33. Okay, that's all. M33, that's all. We can find m11, m22 and m33 from here. And what will be m11? Okay, after eliminating first row and first column, it will be like 0 into 5 minus 1 into 2, that is 2. And what about m22? M22 is eliminating this column, this row and this column, 1, 0, 1, 0, 1, 5, and it will be 5, right? Okay, and what about m33? M33 is equal to 1. Okay, just add it, you will get 7, 8, right? That is plus 8 into a minus, what will be determinant of a? You know how to find determinant of a, right? Just apply that here. That is, okay, that is 1 into 2 plus 1 into 5 minus 2, that is 3. I think the determinant is 5. That is 5 into I is equal to null matrix. Okay, and if you find AQ from this matrix, A square from this matrix, substitute it here, you will get a null matrix. Okay, we are using this technique for solving an enormous amount of problems in a very simple manner. Okay, let's start. I don't remember which year exactly. I think in 2021 there was a question asked, if a student knows the Kaye-Hamilton theorem very well, you just look into the question and you can mark the answer. That was it. Okay. So let's write that question again. That is, what is A inverse? A inverse is equal to alpha I plus beta A, right? Okay. You do one thing. We can eliminate A inverse at first, just by multiplying with A on both sides. And what will you get? You will get I is equal to alpha into I into A is A itself plus beta A square. Okay. If I rewrite it like this, it will be beta A square plus alpha A minus I is equal to null matrix. Okay. So what is the corresponding characteristic equation? That is, after applying Kaye-Hamilton theorem, you will get a quadratic polynomial with this matrix, right? What will be that matrix? That is A square minus, which I have just detailed before, A square minus, what is trace of A? 5. 5A plus, what is determinant of A? That is 4 plus 2, that is 6. 6 into I is equal to 0. Clear? Okay. Since we have a quadratic equation of this matrix and we have a quadratic equation of this matrix also. Both the matrices are same. Okay. Therefore, both of them should be same. Therefore, what I am going to do is, I am structuring this one to this matrix. How we can do that? What should be your initial step for converting this matrix to this matrix? See, the coefficient of A square is 1 here. And what is the coefficient of A square here? Beta. So you need to convert the coefficient of A square to 1 before comparing both the matrices. Okay. So what I am going to do is just divide it with beta and you will get A square plus alpha by beta into A minus I by beta is equal to 0. Okay. So just compare the coefficients and that's it. The problem is over. Therefore, if you compare it, it will be like here the coefficient of I is 6. Here what is the coefficient of I? Minus 1 by beta. Therefore, minus 1 by beta is equal to 6. And what is beta? Beta is equal to minus 1 by 6. Okay. And we know that alpha by beta is equal to what? Minus 5, right? Therefore, alpha is equal to minus 5 beta. Substitute that beta here and you will get alpha is equal to 5 by 6. Okay. And you need to find 4 into alpha minus beta, right? That is 4 into 5 by 6 minus 1 by 6. That is 6 by 6, 1. 4 into 1 is what? 4. Easy one. Okay. As this is the first question, it will require some time. Okay. For both of us. Okay. As I am discussing for you for the first time. Okay. That's why it has consumed this much time. Okay. In the later questions, it will be somewhat lesser. Okay. So please keep this equation, both the theorems, very handy. Okay. It will be very useful for your upcoming examination. Okay. And the next one. Yes. And what will you do for this question? 2023 question. Okay, a square matrix is given and one among those, the matrix is an unknown parameter, that is lambda. And A inverse also given exactly like before, and alpha plus beta is given, and you need to find 4 alpha square plus beta square plus lambda square. Okay. So you need to find all the other parameters, right? We can do that. So what I am going to do is, I am multiplying both sides with A. As I did before, it will be I is equal to alpha A square plus beta A. If I take I to the right hand side, it will be alpha A square plus beta A minus I is equal to 0. Okay. There's one thing which I like to add. So if you are doing questions, objective questions, what you need to do is, don't copy the question in your paper. Okay, don't spend that much time. So even if it takes 1 or 2 seconds or 3 seconds to write that, just don't do this. Okay, do that. Always in your exam paper, in your answer paper, if you are doing it, if you are doing objective question, the first step should be your first line. Okay, like this. I have multiplied this and I have arranged this. See, if you are doing so much questions, then this can be your first step. Okay, while doing that, please be careful with the errors. Okay. So I have reduced this matrix, and there is one more. Since we know that we are going to apply Kaye-Hamilton theorem, I am dividing it with alpha. That is A square plus beta by alpha minus 1 by alpha into identity matrix is equal to null matrix. Okay. Then the Kaye-Hamilton theorem which we are going to do right now, that is A square minus, what is trace of A? 11, right? 11A. What is determinant of A? 10 minus 5 lambda. 10 minus 5 lambda into I is equal to what? Null matrix. We know that both of them are equal, right? Okay. See, here we have 2 equations and 3 unknowns are there. Okay. Normally it won't be that easy, so that they have given you additional equation. So there are 3 equations and 3 unknowns. Now it's easy. So comparing, we know that beta by alpha is equal to minus 11. So what is beta? Beta is equal to minus 11 alpha. Okay. Applied here, you will get beta. Okay. And we know that alpha plus beta is equal to minus 2, right? That is alpha plus minus 11 alpha is equal to minus 2. And you know that alpha plus minus 11 alpha is equal to minus 10 alpha. Minus 10 alpha is equal to minus 2. That is alpha is equal to minus 2 by minus 2. That is alpha is equal to 1 by 5, right? Okay. If alpha is equal to 1 by 5, then what will be beta? That is 1 by 5. Okay. We can apply it here. Here itself, that is beta by 1 by 5 is equal to minus 11. That is 5 beta is equal to 11. That is beta is equal to what? Minus 11 by 5. So we got beta and alpha. Okay. If alpha is 1 by 5, then what is minus 1 by alpha? Minus 5, right? If alpha is equal to 1 by 5, then what is minus 1 by alpha? It's minus 5. Okay. So minus 1 by alpha is minus 5. So this is minus 5, right? The coefficient of I is minus 5. So I am equating the coefficient of I on both sides. That is minus 5 is equal to 10 minus 5 lambda. 10 minus 5 lambda and minus 15, and lambda is equal to 3. Okay. Now you got lambda also. So now you got all the parameters, and I think we can substitute it here. That is 4 into alpha square. That is 4 into 1 by 25 plus 4 into beta square, right? That is 11 minus 11 by 5. The whole square is 121 by 25 plus lambda square, that is 9, right? So 4 by 25 plus 125 by 25, that is 121 by 25. That is 125 by 25. That is 5, and 5 plus 9 is what? 14. 14 is the correct answer. Okay, easy one. Clear? Next one. Okay, it's asked in the previous year. Okay, very short answer type. Okay, but it's massive if you don't know Kaye-Hamilton theorem. It will be massive, okay. A square matrix A is given. Of that, two parameters are there, A and B, unknown parameters. And they have given you an additional equation, additional cubic matrix equation, which this matrix satisfies. And they have stated that I is identity matrix. We know that. And you need to find A and B. Or 2A plus 3B, whichever you can. Okay. So I am rewriting this cubic equation like A cube minus 4A square plus A plus 21I is equal to null matrix. Okay, it is a cubic equation. Okay, so I am going to apply Kaye-Hamilton theorem here. That is A cube minus, what was the first one? Trace of A, right? That is 2 plus 3 plus B is 5 plus B into A square. Okay, we can compare it now itself. There is no need of writing all of it since it's not a board exam. Okay, therefore, what is minus 5 plus B? Minus 4A square. Therefore, 5 plus B is equal to 4, B is equal to minus 1. You got B already. Okay. Plus M11 plus M22 plus M33. Okay. Minus determinant of A into I is equal to 0, right? Okay, that is the sum of minus of diagonal elements and minus determinant of A into I is equal to 0. Determinant of I am written here because I haven't found that yet. Okay, I wrote that yet. Okay, instead of finding the minus, I am going to find determinant. It will consume some time. Okay, therefore I am going to find determinant. Let's see if that works or not. Okay, so what is the determinant here? That is 2 into 3b minus 5. 3b minus 5 minus A into B minus 0, that is minus AB. This is what the determinant is. Open it, therefore it will be 3b minus 5 minus A into B. Okay, that is 6b minus 10 minus AB. We know B already, right? Okay, we will get the answer from here itself. What is B? B is minus 1. Substitute minus 1 here, you will get minus 6 into minus 1 is minus 6. Minus 6 minus 10 is minus 16. Minus 16 plus B is minus 1. That becomes plus A. So what is the determinant? A minus 16. Okay. So here I am putting a bracket and equating it as A minus 16. So here what was the determinant? 21. So let's equate that and you will get minus of A minus 16 is equal to 21. So A minus 16 is equal to minus 21. So A is what? Minus 5. So you got A now. And what is A? Minus 5. Therefore, 2 into A is minus 10 plus 3 into B is minus 1, right? Minus 3. And what is the answer? Minus 13. That's all. Done. Okay. So, if you know this theorem and if you know how to apply it properly, it's very easy. Piece of cake. Okay, next one. Okay. Another one. Very much similar to this one. Okay. Alpha plus beta, right? Easy one. Therefore, I am reducing the equation A square plus beta by, see, if you want you can do it, okay, just hit the pause button and do it by yourself, okay. Beta by alpha into A minus 2 into 2 by alpha into I is equal to 0. Our corresponding equation will be A square minus of minus 1 plus minus 5 is minus 4 into A plus, what is determinant of A? Minus 5 plus 4, that is minus 1, that is minus I is equal to 0. It is actually plus into minus 1 into A, that becomes minus A. Okay, if you compare it, you will get minus 2 by alpha is equal to minus 1. Therefore, alpha is equal to 2. Done. Alpha is done. And beta by alpha is equal to 4 and beta is equal to 8. Alpha is 2, right? 2 into 4 is 8. Alpha plus beta is 10. Done, understood. Okay. See, it's very easy. It's getting way more easier. Next one. Okay, in question in 2024, I think session 2, right? 4th April. Okay, let's check. Let A be a 2 by 2 symmetric matrix. Okay, they have given an additional information that A is a 2 by 2 symmetric matrix such that A11 is equal to 3, 7 and the determinant of A be 1. Okay, they have mentioned that determinant of A is 1. And A inverse is equal to alpha A plus beta I, and where I is an I. Okay, we know that. We need to find alpha plus beta. And how will you find alpha plus beta from this? The question has changed, right? Just hit the pause button, just read the question once more and identify what is changed with respect to the previous question. Okay. Okay, let's check. A be a 2 by 2 the matrix itself is not given. Then how are you going to find this out? Okay, they have given that it is a symmetric matrix, right? So how will you form a 2 by 2 symmetric matrix? Easy. That is A is equal to A, B, B, C. It's a symmetric matrix of order 2. Okay, and they have mentioned that, okay, into 1, 1 is equal to 3, 7. So I am going to write this. Okay, into 1, 1 is equal to what? 3, 7. Okay, they have mentioned one more thing. What is determinant of A? It is hidden here actually. Is 1, right? Determinant of A is equal to 1 means if you take the determinant, that value should be equal to 1. That is, what is AC minus B square? Determinant of A is equal to AC minus B square, that is equal to 1. So AC minus B square is equal to 1. Okay, please note that. And we can multiply both sides. This you know how to formulate. Okay. A inverse is equal to alpha A plus beta. It's a doable question. Okay. Slight changes there. So if I am multiplying with A on both sides, it will be alpha A square plus beta A minus I is equal to 0, right? Divide with alpha, same drill. That is beta by alpha minus 1 by alpha into I is equal to 0. Okay. How will you take this from here? Easy actually. What is the corresponding Kaye-Hamilton format of this one? A square minus, what is the trace of this matrix? A plus C, right? A plus C into A plus, what is determinant of A? They haven't given you any information about the elements inside that matrix, but the determinant of that matrix is given, right? What is that? 1. Therefore, it will be plus I is equal to 0. Okay, compare the coefficient of I, you will get alpha easily. Therefore, what is alpha? Minus 1 by alpha is equal to 1 implies alpha is equal to minus 1. Okay, now you got that. Okay. Okay, let's multiply these two matrices. Okay, let's do that. What is that? Is A plus B is equal to 3, right? A plus B is equal to 3 and B plus C is equal to 7. And there is an additional data which you have, that is AC minus B square is equal to 1. From this data, how will you formulate A, B and C? 3 equations and 3 unknowns are there. It will entirely depend on our algebraic skill to solve this. Okay, it's very easy, basic one, 10th standard level. Okay, but it's a doable question. Okay, then how will you do this? 3 equations are here. Okay, so just think, here we have A and C, right? And here we have 2 equations based on AB and BC. So let's transform this A in terms of B and in this C in terms of B and substitute here. Then this equation will entirely be in terms of B. Okay. Therefore, what is A? A is equal to 3 minus B and C is equal to 7 minus C. Apply that here and you will get 3 minus B into 7 minus C minus B square is equal to 1. Okay, just open the bracket and you will get 21 minus 3Z. Okay, 21. 7 minus B. Okay. 7 minus B. 21 minus 3B minus 10B plus B square minus B square equal to 1 got cancelled. And minus 10B is equal to minus 20, B is equal to 2. Now you got B. If B is equal to 2, then what is A? A is 1 and C is what? 5. Sorry, C is 5. Okay. Oh, it's an integer question, right? So you need to find beta and alpha. Alpha you already got alpha, right? Alpha is equal to minus 1. Okay, we can compare this and this. We know that. Okay, I am taking the next slide. Okay. Beta by alpha is equal to minus A plus C, right? beta by alpha is equal to minus of a plus c. We know that alpha is equal to minus 1. That is beta by minus 1 is equal to, what was the value for a and c? Don't remember. Beta was 2, right? A is 1 and c is 5. So a plus, this is 6, right? A plus c is 6. That is equal to minus 6. Therefore beta is equal to what? 6, and alpha was equal to minus 1. Therefore alpha plus beta is equal to what? 5. That's all. Okay, done. See, they have slightly altered the question. You can expect this if you, they can integrate multiple concepts into a single question. Okay, so many questions are like that. Okay, even you can expect questions from permutations and combinations along with the integral. Okay, I think in the 2023, they have asked a question from sets and conics and ellipse. Okay, so our very next question. Okay, let's see the question. A is a 2x2 matrix, that is 0 to k minus 1. It is satisfying the equation a into a cube plus 3a, which is equal to 2i. Okay, so how will you do this matrix? See, the two methods, the basic conventional method is like this. You can find a cube and substitute it here, multiply again to a and equate it, you will get the value of k eventually. Okay, or else the shortcut one. Fortunately, this problem also we can solve this in terms of Kaye-Hamilton theorem. Okay, so I'm just opening the bracket here and you will get what? A raised to 4 plus I into a is a itself, that is 3a, that is equal to 2i. Okay, so what is a raised to 4? A raised to 4 is equal to minus 3a plus 2i. Okay, the next one, we can find the corresponding matrix polynomial, quadratic polynomial. Therefore, it will be a square minus, what is trace of a? Minus 1 into a plus, what is determinant of a? Minus 2k, right? I'm not equating it, okay, you know how to find that all is equal to 0. Therefore, I'm rewriting this a square plus a minus 2ki is equal to 0. Okay, so we have now two equations. And my question is, how will you equate these two equations? That's very easy actually. Either we need to convert a square in terms of a raised to 4, or that's a hectic method. We can convert a raised to 4 in terms of a square also, but that's will require more time. Okay, so I'm converting this a square in terms of a raised to 4. Okay, so before that, so my objective is to convert a square to a raised to 4 and equate the corresponding coefficients of a and I. That's all, you will get the answer. So what is a? I'm writing a square, expressing a square in terms of a and I. That is, a square is equal to 2ki minus a. So what will be a raised to 4? That is equal to a square into a square. Okay, that is equal to 2ki minus a into 2ki minus a. Okay, what is 2k into 2k? 4k square. I into I is I square, that is I. That is a raised to 4 is equal to 4k square I minus 2k minus 2k, that is minus 4k a. Okay, and plus a square. Okay. The problem here is, now we have converted this a square in terms of a. Our objective is to compare this equation with this equation, right? The problem which will happen is, here we don't have a square, but here somehow we got a square. Therefore, we need to eliminate that a square. And how will you eliminate that a square? It's easy. It's here itself. What was a square? At the beginning of this algebraic operation, we have evaluated a square. What is a square? 2ki minus a. Just substitute that here. It will completely in terms of I and a then. Okay. Therefore, what is a raised to 4? A raised to 4 is equal to 4k square I minus 4k plus a square is what? 2ki minus a. Okay. Therefore, a raised to 4 is equal to, assemble the terms of a, that is, or I. Okay. That is 4k square plus 2k into I, and I took the minus common, that is minus of 4k plus 1 into a. Okay, just compare it with the coefficient of a. You will get minus of 4k plus 1, which is equal to what? Minus 3. Okay, minus of 4k plus 1, which is equal to minus 3. Okay, therefore we know that 4k plus 1 is equal to 3. Okay, if you solve it, the value will be k is equal to 1 by 2. Okay, that's all. And if you equate in terms of I also, you will get another answer, but I think that answer is not in the option. Okay, therefore we can conclude with only one value of k. Since no other conditions is given here, we can go with this value. Okay, I think that's all with this question. Okay, the Kaye-Hamilton. Next one. If alpha and beta are real numbers and consider a matrix A such that a square plus 3a, a square is equal to 3a plus alpha. So like in Kaye-Hamilton theorem, they have stated like this, that is a square is equal to 3a plus alpha I, and they have a raised to 4 is also given. That is, what is a raised to 4? 21a plus beta I. Okay, let's try to find out. So there is nothing to discuss here. This problem is exactly similar to the previous problem. Okay, in the previous problem we need to obtain a square. Okay, it's not like that in here. It's easy. Okay, so I am finding a raised to 4. That is, a raised to 4 is, we know that is a square into a square. That is 3a plus alpha I into 3a plus alpha I. Okay, so that is a raised to 4 is equal to 9a square plus, it will be 6 alpha I plus alpha square I square is I. And we know that we need to convert this in terms of a and I only. Therefore, we need to substitute the alternative value for a square here. The value for a square here. That is 9 into 3a plus alpha I plus 6 alpha I plus alpha square I. So, a raised to 4 is equal to 27a plus 9 alpha I plus 6 alpha I plus alpha square I. Okay, 6 alpha, sorry, not I, it's a. Okay, my mistake. It is a here. Okay, 6 alpha, a plus alpha square into I. Okay, so I am assembling the terms of a and I separately. Therefore, a raised to 4 is equal to 27 plus 6 alpha. 27 plus 6 alpha into a plus the next one will be 9 alpha plus alpha square. That is 9 alpha plus alpha square into I. Okay. Therefore, what is a raised to 4? The given structure is like this. Okay. A raised to 4 is equal to 21a plus beta I, and here a raised to 4 is equal to 27 plus 6 alpha into a plus 9 alpha plus alpha square. Okay. So, I am comparing this. This will be 27 plus 6 alpha was the coefficient of a here. And what is the coefficient of a here? That is 21. That is 21. That is alpha is equal to minus 1. 21 minus 27 is minus 6. By 6 is minus 1. Is that in the option? Unfortunately, no. Therefore, we need to find the value of beta. Just substitute alpha here. Substitute alpha here. You will get 9 into minus 1 is minus 9. Plus alpha square is 1. That is minus 9 plus 1 is minus 8. What's the coefficient of I? And what is the coefficient of I here? Beta. Therefore, beta is equal to what? Minus 8. I think that's here. Okay, D. D is the correct answer. Okay, that's all. So, our very next hope it's clear, and I'm moving to the very next question. Okay, it's an infamous question. P is a square matrix such that P square is equal to I minus P. Watch out for this matrix, okay? And alpha, beta, gamma, psi element of n. Okay, 4 parameters. And it is given that P raised to alpha plus P raised to beta plus, right? Plus P raised to beta is equal to gamma I minus 29P. And P raised to alpha minus P raised to beta is equal to psi I minus 13P. Okay, therefore alpha plus beta plus gamma minus psi is asked. You need to find that out. Massive one, right? Okay, let's try to do that. It's a funny question actually. So, let's start. What is P raised to alpha plus P raised to beta? That is gamma I minus 29p, right? Gamma I minus 29p. Okay, very well. And what is p raised to alpha minus p raised to beta? That is psi I minus 13p. Okay. So you know that if x plus y is equal to 10 and x minus y is equal to 6, you know how to find x and y, right? Just by adding and subtracting. Like that, I'm going to find p raised to alpha and p raised to beta. Okay, let's consider this as equation 1 and equation 2. If I add equation 1 plus equation 2, this will get cancelled and it will become 2 times p raised to alpha. So after the simplification, p raised to alpha will be gamma I plus, okay, gamma plus psi into I. This was minus 42, okay, minus 42p by 2. Therefore, p raised to, sorry, I am writing it here, p raised to alpha will be gamma plus psi by 2 into I minus 21. So, what will be p raised to beta? If you subtract the two equations, you will get p raised to beta, right? Therefore, I am doing it at once. That is gamma minus psi into I. What is minus 29 minus minus 13? That is minus 16 by 2 is minus 8. That is minus 8. Okay, here we have p and here also we have p. Okay, by 2. Okay, minus 16 by 2 minus 8. Okay, fine. So we got p raised to alpha and p raised to beta, and this is the structure of our problem. From this, we need to proceed. And how will you proceed actually? Only a very few students have attended this question. The students who attended this question make it correct, the percentage is very low. Okay, because of the appearance of this question, most of the students will think it is time consuming like that, but it's not that much time consuming. It's a very easy question, moderate question. Okay, and okay, so we have p square is equal to I minus p, right? P square is equal to I minus p, and for the sake we what will be p raised to 4? P raised to 4 will be p square into p square, that is I minus p into I minus p, right? Therefore, what is p raised to 4? I'm writing it here. P raised to 4 is equal to I into I is I square minus 2p plus what? P square. Yes, wait. What is p square? Sorry, this was p raised to 4. Okay, small mistake. And p raised to 4 is equal to I square minus 2p. I square is I minus 2p and plus p square, right? P square is what? I minus p. Okay, it is plus I minus p. Therefore, what is p raised to 4? That is 2i minus 3p. P raised to 4 is what? 2i minus 3p. Okay, it's not matching, right? The p should be either minus 21 or minus 8. I hope you are getting. We need to multiply this and till it reaches minus 8 or minus 21. Only then we will be able to find the answer. Okay, let's try. So I am finding p raised to 8. P raised to 8 is p raised to 4 into p raised to 4, right? That is p raised to 8 is equal to 2i minus 3p into 2i minus 3p. Okay, and p raised to 8 is equal to, what is 2i into 2i? 4i square, that is 4i. Okay, that is minus 6, that is minus 12p. Minus 12p plus 9p square. Okay, that is what p raised to 8. I think, okay, I'm going to delete this part, okay. Just to copy that if you want. Okay, but I want more space here, okay, that's why. Okay, so what is p raised to 8? That is p raised to 8 is equal to 4i minus 2p plus 9 into p square, right? And what was p square? Again I minus p, that is 9 into I minus p. Okay. Okay. 4i minus, it is 12p, okay, not 2p, it's 12p. Okay, my mistake, that was minus 6p and minus 6p minus 12p. And if I open the bracket, it will be 4i plus 9i is what? 13i 13i minus 12p minus 9p is minus 21p. Okay, we got something, right? Yeah, it matches this one. Okay, so from that you got alpha. What is alpha? Alpha is equal to 8 and gamma plus I by 2. That is gamma plus I by 2 is equal to 13. Therefore, gamma plus I is equal to 26. Okay, now like that we need to find where it will hit minus 8p. Okay, for that, see what is p raised to 4, 2i minus 3p, and what is p raised to 8, 13i minus 21p. Okay, so by logic we know that for the value of coefficient should be minus 8, it should lies between p raised to 4 and p raised to 8, right? Okay, let's take p raised to 5 or p raised to 6. Okay, I'm taking p raised to 6 here. Okay, that is, I'm taking the mid value. Okay, so p raised to 6 is p raised to 4 into p square. That is, what is p raised to 4? P raised to 4, yeah, 2i minus 3p. 2i minus 3p, and what is p square? It's given I minus p. Okay, and if you open the bracket, it will be 2i into, that is I, 2i plus 3p square minus 2p minus 3p minus 5p. Okay, we should move to the next page. It gets getting compressed here. Okay, therefore p raised 6 is equal to, okay, p raised to 6 is equal to, I need to shuttle between two pages. Okay, 2i plus 3p square minus 5p. 2i plus 3p square minus 5p. Okay, what was p square again? P square is equal to I minus p, right? Okay, p square is equal to I minus p. Just substitute that value here. Therefore, p raised 6 is equal to what? Is equal to 2i plus 3 into I minus p minus 5p. Okay, so p raised 6 is equal to 2i plus 3i is 5i minus 3p, yes, minus 8p, right? So it's matching. That is, what was p raised to beta? P raised to beta, which we need to find, right? Yes, p raised to beta is gamma minus I by 2 into I. That is, p raised to beta is gamma minus psi by 2 into I minus 8p. It's matching, right? Therefore, what is beta? Beta is equal to 6. And what is gamma minus psi by 2? That is equal to 5. So, what is gamma minus psi? That is equal to 10. So, what was alpha? Alpha was equal to, where is alpha? Okay, 8. Alpha is 8. And alpha plus beta plus gamma minus psi, right? Alpha is equal to 8, and we need to find alpha plus beta plus gamma minus psi, right? We have, I think we have gamma plus psi also here, that is 26. That is, gamma plus psi is equal to 26. From all of this data, we should find this. So, what is alpha? 8, it is here. And what is beta? 6 is already here. And gamma minus psi is already given. Okay, that is 10. We don't want to find a gamma and psi separately. Therefore, it will be 8 plus 6 plus 10. 24 is the final answer. Okay, that's all. I agreed, it's a typical question. It was a typical question, but it was asked in different formats. Okay, the format was different. That I agree, but we have just discussed this question so many times, the concept of this question. Okay, be mentally strong to do this question. Okay, the next question, 2024 first shift, very easy question. Okay, so a matrix is given, cos x minus sin x 0, sin x cos x 0, 0, 0, 1. And two statements are given. The first statement is f of minus x is the inverse of f of x. Okay, and f of x into y is equal to f of x plus y. So we need to identify the truth and falsity of these statements. Okay, that's what discussed in the options. Okay, and in the options, the truth and falsity regarding the statements is given. We need to pick the correct option. So this one is easy. We can find f of x is given. It's easy to find f of y. Just substitute y for the variables x there, and just multiply it and just cross check if it is equal to f of x plus y or not. But for the first one, what you need to do? Just think what you need to do for the first statement. They have mentioned that f of minus x is the inverse matrix of f of x, right? So if two matrices are given such that one is A and one is the inverse of this matrix. So how will you identify that if one matrix is the inverse of the other matrix? There are two methods. As usual, the conventional method is find the inverse of this matrix. How? Using 1 by determinant of A into adjoint of A format. Okay. Or else you can use this technique. Okay. If a matrix is given and A inverse be the inverse of this matrix, then if you multiply the two matrices and you will get what? An identity matrix. Okay, like that. Consider a matrix A and let's consider another matrix B. And it is stated that if B is the inverse of the matrix A and if you multiply both of them, you will get an identity matrix of corresponding order. That's all. Therefore, to identify whether the statement 1 is correct or not, just multiply it and equate to identity matrix. If you are getting it, then the statement is correct. If you are not getting it, it is incorrect. Okay. So there is no space here. We need to move to the next slide. Okay. What was f of x? F of x is equal to cos x minus sin x 0, right? F of x is equal to cos x minus sin x 0, sin x, cos x 0, 0, 0, 1. And what is f of minus x? F of minus x is cos of minus x minus sin of minus x 0, sin of minus x, cos of minus x 0, 0, 0, 1. Okay. So I am applying this f of minus x here. You know what is cos of minus x, right? What is cos of minus x? That is cos x. Cos of minus x is equal to what? Cos x. And what about sin of minus x? That is equal to sin x minus sin x. Okay. So apply both of that here and you will get, it will be cos x minus of sin minus x. This minus will come here. It will become sin x 0 and minus sin x cos x 0, 0, 0, 1. Okay. And if you multiply both the matrices, let's check if it is yielding an identity matrix or not. What is cos x into cos x? Cos square x. Okay. Plus minus sin x into minus sin x, sin square x. That is equal to 1. Okay. And next one is cos x into sin x. Cos x into sin x plus minus sin x into cos x. Minus sin x into cos x. Here it is 0. Okay. No need. Again, sin x into cos x. So this is 1, this is 0 and this is 0, right? Okay. So sin x into cos x, that is sin x cos x minus cos x sin x plus 0. That's 0, right? Again, sin x into sin x sin square x plus cos square x, that is 1. It is reducing into identity matrix, it is 0. Okay, this one 0, this will become 0, again this is 0 and this is 1. So it's an identity matrix. So f of minus x is the inverse of f of x. First statement is correct. Let's go for the next one. We need another slide for that one. Slightly lengthy but it's very easy. Okay. So we need to find f of x into f of y, right? That is cos x minus sin x 0, sin x, cos x 0, 1, 0, 0. Okay. Again cos y. F of y will be cos y minus sin y 0, sin y, cos y 0, 0, 0, 1. Okay. And if you multiply it, what will happen? Cos x into cos y. Cos x, cos y minus sin x, sin y plus 0. Don't need to write that. Again, next one will be minus cos x sin y minus sin x cos y and plus 0. Again, it will be 0. Okay, next one. Sin x cos y plus cos x sin y 0 plus 0. Again, minus sin x sin y plus cos x cos y 0. This will become 0, 0 and 1. So let's try to reduce what's inside the matrix. Okay. So what is cos x cos y minus sin x sin y? An important trigonometric formula, that is equal to cos of x plus y. Here also it is cos of x plus y. And what about sin x cos y plus cos x sin y? It is equal to sin of x plus y. If you take the negative outside, it will be, both of them will be same. Sin x cos y plus cos x sin y. That is minus of sin x plus y. So it is reduced to f of x plus y. So this is equal to f of x plus y. So the statement 2 is also correct. Therefore, we need to pick the correct option from that. So what is the correct option? Yeah, this one, option 4. Okay, very easy question. Next one. Okay, there is a specialty about this question which I will tell after completing this one. Okay, let's explain the question first. Let P is equal to 1, 0, 0, 4, 1, 0, 16, 4, 1, and let I be the identity matrix of order 3. Okay, and Q is given, the general representation, such that P raised to 50 minus Q is equal to I, and you need to find Q31 plus Q32 plus Q21. Okay, that's elements of Q. And what is Q? Q is equal to P raised to 50 minus I. Okay, Q is equal to P raised to 50 minus I. So what will you do for finding P? Let's check that out. See, the question is, for doing this one, to get the final answer, you should know to multiply matrices. All of you should know that know how to multiply matrices, right? Yeah. And the next question which you should ask yourself is it possible to find the value of P raised to 50 just by multiplying up to P 50 times? Or in bit, that is, or like the continuous process of multiplication, will you get P raised to 50? You will get P raised to 50, but is it necessary to find P raised to 50? That's my question. That's the obvious question which you need to ask yourself. No, for higher powers of P, it is not difficult. It is not necessary. Okay. So what I'm going to do is, I'm going to find P square and PQ. And by doing so, the elements inside the matrix will change somehow. And I'm going to check whether there is a pattern for changing that. And if there is a pattern, and if I identified that pattern, we identified that pattern, it's easy to find P raised to 50. Okay, and that is why, that is the mechanism for doing this question. Okay, again, it's a very infamous question. I'll tell you what makes it more infamous. Okay, so what is P square? P square 1, 0, 0, 4, 1, 0, 16, 4, 1 into 1, 0, 0, 4, 1, 0, 16, 4, 1. Okay, that is P square is equal to, this is 1 and 0, 0, 4, 8. Again 1, 0, this one, 16 to 1, 16, 16, 48, right? And next one, 0, 8, 0. Okay. This 16 is changed into 48. This 4 is changed into 8. Now there is no, okay, this is 1. Okay, my mistake. Okay. All the other elements has not changed. All the elements under the diagonal elements are changed, and no elements including the diagonal elements. No elements above the diagonal elements and including diagonal elements hasn't changed. Okay, let's find P cube here without wasting much time. Therefore, P square into P, that is 1, 0, 0, 4, 1, 0, 16, 4, 1. Okay, so P cube will be, the first element will be 1, of course. Next will be 0, 0, and what about the next one? 8 into 1, 4 into 1, and 0, that is 12. Okay, and next one is 1 itself. Next one is also 0. What about the next one? 48 into 1, 48. 8 into 4 is 32, 16. That is 48, 96. Okay, 96. And next one is 48 into 0, 0, 8 and 12. 12. Next one is 1. Okay, PQ is like this. So, positive changes, right? That is, this element and this element is changed according to the power of P, right? This is 4 into 1. For P it is 4 into 1. And for P square it is 4 into 2. Here also 4 into 2. And P cube it is 4 into 3. And here also 4 into 3. So what will be the elements in P raised to 50? Okay. It will be 1, 0, 0, 12, 1, 0, 12, 1. Okay. Here is what we need to fill, and that's where it gets more tricky. That is, if it is P raised to 1, then the corresponding value will be 16. And if it is P square, the corresponding value will be 48, that is 60 into 3. And if it is P cube, the corresponding value will be 96, that is 60 into 6. So how will you find the pattern from here? What is the pattern among the numbers? Here it is 1, 3, 6. There is a simple and beautiful pattern here. Could you identify that? Just hit the pause button and try to identify the pattern. What will be the pattern for P raised to 4? So here 16 into 1, 16 into 3, 16 into 6, and what will be for P raised to 4? It's easy actually. It is 16 into 1, right? Here it will be 16 into 1 plus 2. 1 plus 2. Here it will be 16 into 1 plus 2 plus 3. And here it will be 16 into 1 plus 2 plus 3 plus 4. And what will be the corresponding element for P raised to 50? For P raised to 50, it will be 16 into 1 plus 2 plus etc. plus 50. It is the sum of first 50 natural numbers. Therefore, we need to move to next slide. Okay. Therefore, P raised to 50 is equal to 16 into sum of first 50 natural numbers is 50 into 51 by 2. That is n into n plus 1 by 2, right? Okay. If we cancel it, will be like 8. 8 into 50 is 400. That is 400 into 51. Okay. You don't want to multiply it further. You know that Q is equal to, and what was Q again? P raised to 50 minus I. Okay, P raised to 50 minus I. I think we got P raised to 50 already. That is 1, 0, 0. Again 1, 1. It is 0. It is 4 into 50. That is 200, right? We can write that directly. Okay, that is 200. Here also 200. Here it will be 400 into 51. Okay. So, what do you need to find here? I think 3132, right? That is Q31 plus Q32. Okay, divide by Q21. Okay, divide by Q21. Okay, it is minus I is also the 1, 0, 0, 0, 1, 0, 0, 0, 1. See, if you add with I or subtract with I, it will have no change in your final answer. Why? Because if you are subtracting this with I, only the diagonal elements will get 0. Okay, all the other elements will have no change. So, if you add or subtract with P, these elements will remain same. And that is the elements which you need to calculate to get the final answer. Okay. So, what is Q31? That is 400 into 51 plus what is Q32? 200 divided by, and what is Q21? That is 200. Okay. Just cancel the zeros and the 2 also 2. That is 2 into 51 is 102. And 102 plus 1 is what? 102. 102 plus 1 is 103. Okay. As I mentioned before, it was an infamous question because it was asked in JEE Advanced 2016. And at that time, a very few percent, I think less than 5% of the total students who attended for the exam answered it correctly. But it was a very easy question. Once you formulated that the corresponding terms of 16, it was very easy. Okay. So, just one more thing. I am going to tell you a shortcut for this matrix. Okay, that is, this matrix was like this: 1, 0, 0, 1, 1. Here also it was 0, right? A, B, A. And if it is P, then P raised to n is equal to 1, 0, 0, N, A, 1, 0, n into n plus 1 by 2 into B, n, A, 1. Okay. Using this, you will easily get the answer. Okay. Why I have told you this matrix and I have detailed this matrix? Because nowadays they are asking problems based on the concept of this question. Okay, using the essence of this question, you can easily solve those matrices. Okay. This one, exactly similar to the previous question. Okay. Q minus p raised to 5. Okay, p is given, q is given. Q minus p raised to 5 is equal to, it's I3. Very much similar. That is, q is equal to what? P raised to 5 plus I. There is no need of adding p raised to 5 with I, because only the diagonal elements will change, and diagonal elements have no impact on the final answer. Okay, so I am neglecting this one for now. So what is p raised to 5? It's very easy. P raised to 5 is 1, 0, 0, 1, 1, 0. P raised to 5 is multiply here with 5. Therefore, it becomes 15. It also becomes 15. NA, right? And here it becomes 9 into p raised to 5, right? 1 plus 2 plus 3 plus 4 plus 5. Okay, that's 9, 12, 14, 15. 15 to 9 is 135. Okay, done. The problem is over. Okay, so it will be Q21 plus Q31, right? Q21 plus Q31 is this one. 135 plus 15 is 150. Divided by 15 is 10. 10 is the final answer. Done. That's all. Okay. For these types of questions, if a matrix, somehow a matrix is asked which is different from this one, just multiply 2 or 3 times, you will eventually get the answer. Okay. Sometimes it might get tricky somewhere, but eventually you will get the answer. Next one. This is another matrix like this. Here, a raised to n will be, okay, there is a shortcut for find. See, you can find the solution just by multiplying a square a cube like that. And I am going to detail a raised to n, that is 1, 0, 0, no change, 1, 1, 0, no change here and here. It will be NB, it will be NA. Here it will be n into n minus 1 by 2 into AB plus NA. Okay. The element in the position 3, 1, it will change slightly. Okay. And which is equal to, the matrix is given 1, 0, 0, 48, 1, 0, 2, 1, 6, 0, 96, 1. Okay. So let's compare this. After comparing, it will be like NA is equal to 48, NB is equal to 96, right? Okay. Therefore, what will be this one? That is NA plus n into n minus 1 into AB by 2 is equal to 2160. Well, we know that NA is equal to 48, right? So what is NB? NB is equal to 96, right? And what is 96 by 2? 48. Again, we got 48 there. Okay, therefore it will become 48 into n minus 1, 1a is there, is equal to 2160. Okay, take 48 to that side, it becomes 2112. Okay, therefore, and divide it with 48, that is n minus 1 into a is equal to 2112 divided by 48. We need to divide that. That is 2112 divided by 48 times 4, I think it's 192. Again 1944. Okay, that is, which is equal to 44. Just open the bracket. So it becomes an minus a is equal to 44. What was an? I think it's 48, right? Okay, substitute 48 here. You will get the value of a. What is the value of a? 4. Okay, if a is 4, what is n? Just find from here itself. A is 4, then n is equal to 48 by 4, that is 12. And if n is 12, you will find b also. That is 12 into b is equal to 96. That is b is equal to what? 8. Therefore, you got a, b and n. That is 24. That's all. So, integer type question. Okay. The essence of the 3 questions was same. Okay. And the next one. So, our last question from this session. Okay. A square matrix A is given and another column matrix B is given, and it is stated that AB is equal to B, and it's also stated that A plus D is equal to 2021, and you need to find the value of AD minus BC. So many parameters, right? So let's multiply it first. Therefore, it is stated that AB is equal to B, right? That is A, B, C, D into alpha, beta which is equal to what? Alpha beta. Okay, just open it. That is, it will be A alpha plus B beta, which is equal to alpha. C alpha plus D beta, which is equal to beta. And it is given that A plus D is equal to 2021, and you need to find this one. 4 parameters are there. Okay. So my question is, how many unknowns are there in these two equations? Alpha, beta, A, B, C, D. 6 unknowns are there, and you have only 2 equations with you. How are you going to solve this? See, the common logic is like this. If you have 2 unknowns and 2 equations, it is easy to solve. 3 unknowns plus 3 equations, easy to solve. Otherwise, it might get tricky somewhere, but it's doable. So, how are you going to do this question? Actually, this question is very easy. Just basic algebra is necessary for this one. The first thing which you need to do here is, we know that alpha and beta are unnecessary terms here, right? Therefore, it's not in the game. Therefore, A plus D is equal to 2021 and AD minus BC, which you need to find. Okay. And alpha and beta, there is no use of alpha and beta here. First thing you need to do is eliminate alpha and beta. And how are you going to eliminate alpha and beta? That we can do it from here. We can rewrite it if you want. That is B beta is equal to A alpha in minus A alpha. That is B beta is equal to alpha into 1 minus A. Okay, and I'm taking this beta here. It will be beta minus D beta is equal to C alpha. Okay, that is 1 minus D into beta is equal to C alpha. So, you got 2 equations in terms of alpha and beta, and how are you planning to eliminate them? Just divide it. Okay, just divide it, you will get an equation without alpha and beta. That is B by 1 minus D is equal to 1 minus A by C. Okay, so now also our concern is we do not know any one among the 4 parameters. Then how are you going to proceed this? Yes, be mentally strong and just cross multiply it, you will get the answer. How? You will soon find out. Just cross multiply this and you will get BC is equal to 1 minus A into 1 minus D. Open the bracket, it will be like BC is equal to 1 minus D minus A plus AD. Okay, what you need to find here? AD minus BC, right? Just take this BC to the right hand side and take everything to the left hand side. Okay, I am doing it here. And it will be AD minus BC is equal to, okay, AD minus BC is equal to, okay, 1 plus, minus 1 plus A plus B. Okay, I took 1 minus D minus A to one side and BC to one side. Okay, so it will be AD minus BC and minus 1 plus A plus D. The answer is here. Okay, what is A plus D? 2021. And what is 2021 minus 1? 2020. That's it. That's what you need to find, right? Therefore, AD minus BC is equal to 2020. Okay. And that's all for today's session. Okay, I hope you got some idea regarding matrices. Okay, and just do one thing. Just try to solve all the questions by yourself. After watching the video, just try to solve all the questions just once by yourself. You'll get more idea from this topic. Okay, so in the next topic, we'll be discussing determinants and the properties of adjoint determinants and like that questions. Okay, also some important questions based on the multiplication of matrices. Okay, and in that session also, we will be discussing shortcuts, conversion methods, and some important theories. Okay, so stay tuned and thank you for listening. Okay.